All right. Thank you very much, everybody, for coming. We have a lot of slides, so we're going to go right into it. My name is Huang, and we have our colleague, Roman, with us, Fernandez. We work for Armorize Technologies. I'm co-founder and CTO to Armorize Technologies. So today we're going to be talking about Drivesploit, circumventing automated and manual detection of browser exploits. What's up there is the Chinese wording for drive-by download, which actually existed for many years before the term drive-by download came about, because this type of attack was quite prevalent in Asia. I was doing research. I was doing black box scanners at that time, and we weren't able to crawl a lot of the web pages because of the dynamic content, so we started to embed IE. And then we wanted to have mass crawling and SQL injection results. We had many crawlers crawl for many days, and then the end result was all of the boxes ended up with malware in it. We're like, oh my gosh, so what happened? So actually, we submitted a paper to the WWW conference in 2002. In the paper, we described how we embedded IE, and because we had to embed IE, we had to sandbox IE in order to prevent these exploits from attacking our IE. So that was how this technology started. The slides are not in your CD. Apologize. It's right now on SlideShare. So if you go to www.drivesploit.org or you follow the Twitter, you can download it right now. So today we're going to be showing one type of browser exploit, which is the drive-by downloads. Let's define that. So hackers distribute malware by poisoning legitimate websites. And what's typical is they inject malicious iframes into HTML content, malicious iframes into legitimate HTML content. And the affected websites essentially become a delivery mechanism for malware. They appear normal, and the victims do not need to click or agree to anything. They simply connecting to the infected website executes the attack. Recent incidents include the Aurora incident, which began sometime in June last year until February of this year, when Google reported and the news went to the media. It was a targeted attack. It used the IE 0-day and was confirmed publicly by Google, Adobe, Juniper Networks, and Rackspace, and a total of 34 organizations were targeted, according to coverage on media. A recent one, DNF 666. If you haven't heard of this, you can go to our blog. Just Google for the keyword. It started since March 2010, initially leveraging Adobe 0-day. The victims included Wall Street Journal, Jerusalem Post, and then we later found out that all of that effort was just to steal online accounts to online games in Asia. So the second wave and the third wave targeted only Asian websites, while the first wave hit Wall Street Journal and Jerusalem Post. And it happened to CNN, GameSpot, US Treasury, Sony PlayStation, Washington Post in the past. So let's dissect drive-by downloads. What happens is very simple. The visitor links to an exploit server. The exploit server serves him a legitimate page, but it includes a browser exploit and also a payload, or what we call downloader. The exploit, and this part is usually obfuscated. So when it executes, it will deobfuscate itself, and then it will exploit the browser. And at this time, the dropper will execute, which is the payload or the shellcode. And it will cause the browser to link back to the malware server. And the malware server, which is usually different from the exploit server, will distribute malware back. And then finally, the malware will link to a CNC. And that's basically the attack. It's very simple. But now the key is, who would visit a exploit server? Nobody would. So the key here is traffic. And actually why these two servers are usually separate is because, at least in Asia, it's two ecosystems. There are people, there are groups responsible for developing the browsers, and then developing the browser exploits, and then there are groups responsible for getting traffic to the exploit servers, and then there are groups responsible for developing the actual malware, which is quite hard because that malware has to bypass antivirus. And so what happens is you would typically, the attacker would try to infect one of the very high traffic websites, what Google calls the landing website. And then so from there delivers a URL generator, which is a piece of JavaScript that generates iframes or JavaScript sources typically. And this iframe would then cause the browser to start loading content from the exploit server. Recent incidents, DNF 666, and then in May to June, there was mass shared hosting compromise, which included GoDaddy, Rackspace, Network Solutions, Bluehost, and DreamHost. Some of these, after being compromised, wasn't used to serve drive-by downloads, but instead other types of malware, such as fake antivirus. But some were after compromise, were serving drive-by downloads. And then this is a part of a very typical continuous targeted attack, the same incidents to Aurora, that basically is a persistent threat. That's a continuous threat. And when this happens nowadays, it's very easy. It's very hard to remove because a lot of times the URL generator is inserted not into just a plain PHP file, but it would disguise itself as a legitimate WordPress or Joomla file, or it would insert itself into a WordPress store procedure or a Joomla somewhere in the Joomla database. So and it's going to take you a lot of time and a lot of SQL commands to dig that out. And all throughout this time, you wouldn't know how to remove that malicious iframe or malicious JavaScript from your website, and that makes you look very bad. And that was all we've talked about so far is only one type of malicious JavaScript injection, and that is when they physically tamper your data. Another type is when they don't physically tamper your data. Typically, what happened for many years in the past in Asia is attacks coupled with ARP spoofing. So, for example, the ZXARPS tool is very, very mature, very robust. If the attacker is able to compromise other machines on the same lane segment as your web server, they may not choose to infect the web server directly because it then is very easy for you to find the injection and fix it. They would compromise another machine that can do ARP spoofing and then would use a tool like ZXARPS to act as man in the middle, and then it would become the man in the middle, and then it would just basically be passing traffic through, but for every HTTP response that it gets from the server, it would inject a malicious script or iframe and then pass it back. So in that case, you think your visitors tell you that your website's compromised, you go in, you dig the database, you dig the files, you don't find anything, well, because they haven't tampered anything. In March 2009, what happened was websites like tw.msn.com and taiwan.cnet.com and other sites was attacked and embedded with malicious content. And down there you can see a Cisco advisory regarding it. The incident lasted a total of 12 days before it was totally contained, because what happened, as we figured out, was the injection was in the middle of the route. So it wasn't on the lane, it wasn't on the web server itself, but it was on one vendor's equipment that was a Layer 4.7 equipment in the middle of the route that was compromised and that was used to inject the iframes. So this is the second type of this type of attack. So now we're going to do a live demo using Dig, using a persistent cross-site scripting vulnerability in Dig. They have fixed this vulnerability already, but our link is still there. So let's go to Dig first. Firefox, where are you? Oh, lovely Firefox. Okay, there we go. Safari. That's all right. Okay, so usually when you view one of the Dig pages, what you see is this. You would see the digged link and the description and people who dug it, this kind of thing. But let's look at the source code. Oh, jeez. There we go. All right. And here you would see that, let me just zoom it for you because the room is so big. That includes www.zcrack.org/g. And it's included as an iframe source, right? As you see here, which shouldn't happen. So it's a very simple persistent cross-site scripting that exists in Dig, and the attacker, who is us for the demo, has used that to inject that iframe. So let's start our Drivesploit. Okay. So we've implemented the Drivesploit framework on top of Metasploit. So now I'm starting Metasploit. Get this window smaller. And let's, exploit. And let's go to the victim machine. Visit the Dig URL. Okay, so as you can see, Metasploit serving, and we've chosen to use Meterpreter as the payload. And now Meterpreter is starting a new process in Notepad and migrating itself into Notepad. It's completed. Okay, so as you can see, the Internet Explorer is gone, but we now have an open session. Connect to it. See all the processes. So we basically have now a shell into the victim's system. So let's just kill ourselves. And it's attached to actually another process, notepad.exe, so that even though IE is dead, it's all right. So I'll kill myself. Okay, so that